Hey everyone, and welcome back to the lab. We have a really fantastic explainer lined up for you today. We're officially stepping into the modern Kotlin-first era of Android development. Now, if you've been working with Android for a while, you probably know the traditional drill. But man, things have evolved rapidly. Today, I'm going to be your lab partner as we walk through a hands-on project together. We're building a fully functional, one-screen Android calculator app. But we aren't just building an app. We're actually exploring a fundamental shift in how user interfaces are constructed and compiled today using Jetpack Compose and Gradle. Okay, let's dive right into this by addressing the massive elephant in the room. If you're a traditional Android developer, your first question is probably, wait, where did the XML layout go? For years, developers have dealt with the sheer exhaustion of writing UI in those cumbersome XML files, and then, awkwardly connecting them back to their Kotlin or Java code. Well, Jetpack Compose is basically the declarative savior we've been waiting for. It allows you to write your UI directly in Kotlin, completely eliminating that painful XML separation. So to make this learning journey as efficient as possible, here's our agenda. First, goodbye XML, hello Compose. Second, building the calculator UI. And third, building with Gradle. Section 1, goodbye XML, hello Compose. All right, when you fire up Android Studio and start a brand new project, you're faced with a pretty crucial choice right out of the gate. You have to select empty activity. And hey, make sure you don't accidentally choose empty views activity. This distinction is absolutely critical. Choosing just empty activity is what tells Android Studio that you want a modern Compose project. It'll automatically set up the necessary Compose plugins, build features, and all those dependencies in your Gradle files entirely behind the scenes. And this leads us to the biggest shock to the system for veteran developers. Once your project actually loads up, if you look at your resource folder structure, you're going to notice something is missing. There is literally no res/layout folder. And no, it isn't a glitch. This omission is actually the central teaching point of modern Android development. Compose just doesn't require XML layout files for your visual screens anymore because the layout is now constructed entirely from Kotlin code. Let's just compare these two worlds for a second. In the old views system, you had a layout XML file and a view class, and you had to manually tie them together using the absolutely dreaded find view by ID just to say change some text. In the Compose way, that entire exhausting workflow is totally replaced by @composable Kotlin functions and state variables, like mutable state of. You basically just declare what the UI should look like based on the current state, and Compose handles the rest. No more manual UI updates and no more massive boilerplate files. It's a total game changer. And because we no longer have that XML layout file to reference, we also get to say a very happy goodbye to the old setContentView call in our main activity. Instead, the entry point for a Compose application is simply setContent. You literally just pass your composable functions right into this block, and that is what connects the Android activity directly to your shiny new Kotlin UI code. Moving right along to Section 2, building the calculator UI. So here's the final goal of our lab running in the emulator. It's a really simple, elegant one-screen calculator. As you can see, you've got text fields for your first and second numbers, a nice row of circular operation buttons, and result text right at the bottom. Notice how clean it all looks? That's entirely driven by Compose's Material 3 components directly from Kotlin. And the best part, this is exactly what you'll see in Android Studio's interactive preview as you build it. Now, to build that screen, we use Compose's fundamental building blocks. Think of it like Lego. Vertical lists of items are wrapped in a column. Horizontal lists, like our operation buttons, just go in a row. Stacked items use a box. There are no more rigid linear layouts or constraint layouts that you have to configure in a totally separate language. You also get built-in theming with Material Theme. And honestly, if you ever need scrolling lists, lazy column and lazy row completely replace the massive headache that used to be the recycler view. But if you take one thing away from this, it's this magic word, recomposition. In traditional Android, if data changed, you had to write specific code to manually tell the UI to update, like calling notify dataset changed. With recomposition, Compose automatically redraws only the specific parts of the UI affected by state changes. You literally just update a variable and the screen instantly reflects it. It's almost like magic. Let's see how that actually works in our calculator's flow. Step 1. The user types their first input, and our code updates the first state variable. Step 2, they type the second input, which updates the second state variable. Step 3, a math operation button is clicked. And step 4, the calculate function runs and changes the result text state. Because result text is a Compose date variable, the displayed text on the screen automatically updates. Boom! That is recomposition in action. Simple, direct, and incredibly fast.
And that brings us to Section 3, Building with Gradle. Inside Android Studio, your app folder and Gradle build scripts sit right side by side. Now, while the IDE provides an incredibly helpful graphical interface with play buttons and visual layouts, the actual workhorse, the thing managing your dependencies, compiling your Kotlin, and truly building the app under the hood, is Gradle.
You can think of Gradle as the engine under the hood, kind of much like NPM for Node or Make for C. Here is its 4-step lifecycle in a nutshell. First, it compiles your .kt and .java files straight into bytecode. Second, it processes any remaining resources, things like your launcher icons and strings from the res folder. Third, it runs necessary tasks like linting and unit tests. And finally, it packages the whole shebang into an installable file.
Depending on your end goal, Gradle creates very specific outputs. Say you're sideloading or testing locally, well, you're going to want an APK, which is the actual installable Android package. But if you're uploading to the Google Play console, you use an AAB, which is an Android app bundle. And the tool you use to actually push that APK onto a physical device from your command line, that's ADB, the Android Debug Bridge. I absolutely love this analogy from the lab notes. Think of it this way. ADB is the screwdriver. APK is the thing you're installing, and AAB is the flat pack furniture you ship to Google. Honestly, that brilliantly summarizes the build outputs. Google takes that flat pack AAB and generates optimized, device-specific APKs for every single user that downloads your app. And since Gradle is fundamentally a command line tool, you don't even need Android Studio open to build your app. By running .gradlew assemble debug from PowerShell, your terminal, or anywhere else really, Gradle will do all the heavy lifting and spit out an APK ready for testing. This is the exact same basic idea used in CI/CD systems. Build servers don't click buttons on a screen. They run this exact script directly to compile your work.
So the crucial point here is this. Your entire app, from the complex backend logic all the way down to every single button on the screen, is now just Kotlin code. Which brings me to a final kind of provocative thought to leave you with today. How will moving to an XML-free, 100% Kotlin codebase change your automated CI/CD workflows? Just think about how much easier it is to inspect, refactor, and version control your app when the UI isn't hidden away in a completely separate layout language. I highly encourage you to open Android Studio, pick empty activity, and try this modern workflow yourself. Thanks so much for joining me in the lab today for this explainer, and keep building.